Welcome back, viewers. In today's video, we are going to solve another free fall physics problem, and we will use kinematic equations to solve it. So the problem is, from the top of a building with a height of around 60 meters, a rock is thrown directly upward at an initial velocity of 20 meters per second. What is the rock's velocity at the instant of hitting the ground? So we will use CoPilot to solve this problem, and then we will compare the results with the human tutor who has solved the problem here. So to find the rock's velocity at the instant it hits the ground, we have to consider two phases of motion, the upward journey and the downward journey. Here we shall use the equations of motion under constant acceleration due to gravity. So given data is initial velocity u is 20 meters per second in the upward direction. Height of the building is 60 meters. Acceleration due to gravity g is 9.8 meter per second square in the downward direction. First step is to find the maximum height that is reached by the stone or the rock. So using the equation of motion v is equal to u minus gt. So 0 is equal to 20 minus 9.8 t. So t is 20 upon 9.8, that is 2.04 seconds. So the final velocity is assumed is v is 0 because when it will reach the top of the upward travel, where the velocity will come down to 0 and then it will start a downward fall. So that's why v is to be taken as 0. Initial velocity is 20. G is the gravitational acceleration and t you have to find. So answer is t is equal to approximately 2.04 seconds. Now using the second equation of motion to find the maximum height h reached before the reach above the building. H is equal to ut minus half gt square. So h is 20 into 2.04. So the time we have found it here, we have to put it here. U is the initial velocity minus half into 9.8 into 2.04. That is the t. You have to square it, and finally you get h is 20.41 meters. So the total height achieved by the rock will be 20.41 meters. Now total height from the ground will be h total is 60 plus 20.41 because 60 meters is the height of the building, and from the top of the building it has the person has thrown a stone or rock in the air. So 60 plus 20.41 is 80.41 meters. That is the total height. Now calculate the velocity at the ground impact. So v square is equal to u square plus 2gh. So here u is equal to 0 because it starts falling from the rest at the topmost point, and h is 80.41 meters. So v square is equal to 0. We have taken u is equal to 0 plus 2 into 9.8 into 80.41. So v square is 19.6 into 80.41. So v square is equal to 1572.04. So under root of v is 39.666 meter per second. So the rock's velocity at instant it hits the ground is 39.66 meters per second. So now let us see if any differences are there. So here they have used the equation v square minus v0 square is equal to minus 2g and delta y. That is the difference in height. So 2 into, they have taken approximation, instead of 9.82 they have taken 10, and v square minus 20, 20, what was 20? Yes, 20 is the this initial velocity in the upward direction. So v square is equal to 1600, v is equal to 40 meter per second. Now, I will tell you that this is okay. It is the shortest answer. But if you want to understand really the problem, then you have to use this method. This is, you can say, very simple. It is lengthy, but it is simple and it is well understood, good for understanding the problem and the problem solution. So if you use this, your basics will be very clear. This is also good. This is for the advanced user. So if you are new to the kinematics problem, free fall problems, then you use this. Once you understand this, then you can use the solution given by the human tutor. But I will prefer to go with the CoPilot solution, because though it is lengthy, it is very well described, it is very well laid out, and any new student can understand it better than the solution, short solution given by the human tutor here in the solution book. So on this note, I will stop the video here. In the next video, we will try out some more physics problems. Maybe we will go with the projectile motion. So see you in the next video. Bye.